Morning or afternoon, everyone. I hope you're all having a fantastic day as usual. Today we're going to be talking about the not so simple side of harmonic motion. Yesterday we talked about simple harmonic motion, which was relatively an easy concept, mainly because it's just something oscillating back and forth. Well, the not so simple is going to be pretty much the same thing, just now we're going to have the option of moving our sine or cosine wave around. So a couple of things that we're going to get into here is the transformations when you're sliding something up, down, left, right, and then also changes in our amplitude, period, all the jazz that goes along with that. Alrighty, let's get started. Excuse me. So this is starting off here. It says, not so simple harmonic motion. Suppose that the length of time between consecutive high tides is approximately 12.5 hours. So I'll go ahead and underline that 12.5 here. It says, in Savannah, Georgia, high tide occurred at 3:30 a.m. on June 28, 1997, and low tide occurred at 9:45 a.m. So at 3:30 a.m. and at 9:45 a.m., that's when that's the difference between the high tide and the low tide. Notice that is about halfway between your 12 and a half hours. So the 12 and a half hours is between high tide and high tide. So the distance between 3:30 a.m. and 9:45 a.m. is going to be the difference between a high tide and a low tide. It says the depth of water at high tide was 13.2 feet and the low tide was 2.2 feet. So I've written a couple of formulas here. This is just all your stuff from your previous section of notes, or number 4. A is max minus min over 2. B is 2 pi over p. Your K value, which is what you're moving up and down, is your maximum minus your A. Okay? So there's a couple of things that we need to kind of set out here. I'm going to bust up my axes here. Now, if I were to start this thing at 0, which I should always try and start it at 0, 0 here, so t equals 0, is midnight, right? And that's June 28th, so that's midnight 6:28, just in case there's something to do with the dates later on. All right, so you've got your midnight, so at 3:30, so this will be 3.5, 3:30 a.m. That's where we started. At 9:45, that'll be like 9.75, 9 3/4. And then at 12 and a half hours later. So look at this right here. Well, actually, you know what? Hang on. If you think about the 12 and a half, it's going to go from 3.5, right? So 12 and a half hours later, if you add 12.5 and 3.5, you get 16. So over here at 16, this should be when the next high tide is. So it should go from high tide to low tide to high tide, right? And then you know that your this is obviously T for time, right? This is going to be your T. This is going to be your depth, since it's talking about the depth of water. And it cycles back and forth between 2.2 and 13.2 feet. Right? Now let's go ahead and label some stuff here. We've got an amplitude, which is going to be your high, 13.2, minus your low of 2.2 over 2. So your amplitude is going to be 5.5. Your value for K is going to be your maximum, 13.2, minus your amplitude of 5.5. So your K is going to be 7.7. Then you've got your value for B. Now let's talk here. Let's go ahead and get this sucker graphed. At 3:30 a.m., you were at high tide. right? At 9:45, you are at low tide. And at 16, 12.5 hours from your first high tide, you're back at high tide. So here's kind of the way the graph's going to look. Now let's answer some questions here. From high tide to high tide, that means that this entire distance is your period, right? Your period, again, from the question, was 12.5. So for your B value, you're going to take 2 pi and divide by 12.5. All right? Now, if you want to simplify that, we certainly can. We're going to have to multiply the top and bottom by 10 so that we can move that decimal point over. We end up with 20 pi over 125. And that'll simplify to 4 pi over 25. Both those are divisible by 5. So we've got A, we've got K, we've got B. We know how far it's moving over. That's pretty much all we need. And we can go ahead and go to part B right here, which is write an equation to model the water. So see, once we get all these little bits of information, writing the equation is easy. You know your amplitude, you know your B, you know your K, you know how far over you had to start this thing. So the question is this going to be a cosine or a sine graph? Well, since you're starting with a maximum, let's call it a cosine graph. So f of t, since we're dealing with time, is going to be, we've got an amplitude of 5.5. It'll be positive 5.5 since we're starting on an uphill. We're going to use cosine. We've got a B value of 4 pi over 25. And then your x value, or the shifting left and right, you're starting right 3.5, so it's going to be x minus 3.5. And then plus your k value of 7.7. Now I need to stress something right here because there's been some issues with how we're writing equations, namely how we're entering them in the calculator. The cosine of 4 pi over 25 times x minus 3.5, all of this is what you're taking the cosine of. Okay, so when you type it in the calculator, it should be cosine parentheses 4 pi over 25 parentheses x minus 3.5 close parentheses close parentheses. You're taking the cosine of all of the stuff on the inside here. Okay, that is something we need to get straight. Because now it says to enter the equation into a graphing calculator and answer the following questions. Well, I've gone ahead and done that for you here. 5.5 times cosine of 4 pi over 25. See how I've used 2 open parentheses there? Of x minus 3.5, close parentheses, plus 7.7. Now on your window, my x values need to go at least up to 16, so I went to 20 just to make sure I had plenty of room. My y values, I went from 0 to 15, again, just so I can make sure I have plenty of room. So my maxes should happen at 3.5, and the question is asking, when did the next high tide occur? Well, you could take it from your graph up here, or if you didn't know that already, if you didn't know what your period was, you could use your calculator, go to trace, or second calculate rather, and find your maximum. And I want to use, you can see my cursor moving here, I want to use this right hand side, so I want to do a left boundary, a right boundary, and I want to test it. So my maximum happens at 16. Now your calculator is not perfect, so it's going to say 16 point blah 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 3. But yeah, it's close enough. So when did the next high tide occur? That happens 16 hours. Or if you wanted to say that in terms of actual time, it's 16 hours after 3.5. So 16 hours after 3, right? Or I'm sorry, 16 hours after midnight, rather. It's 12.5 hours after 3, 16 hours after midnight. So we could say it's or 4 p.m., right? And that's on 6/28, same date. So we could say it's 16 hours or at 4 p.m., 16 hours after midnight, 12.5 hours after 3.5. And then what is the water level at 11 p.m. on that day? Now, this one is asking us for the actual water level, the Y value. This is wanting to know when is Y 11? Okay, since this is a calculator problem, I showed you on the video yesterday, I showed you how to do that one by hand. But let me show you how to use a calculator for that real quick. What I'm going to do is go to Y2, all right? Or no, I'm sorry. Blah, blah, blah. I'm sorry. It gave me a time. It gave me 11 p.m. What am I thinking? It gave me a time of 11 p.m. So that one's actually a lot easier. I can just hit trace, type in 11 for my X value, and at 11 p.m., here's my Y value. Oh, wait. Huh. Okay. Yeah, that's fine. Oh, no, it says 11 p.m. That's 11 a.m. Shucks. 11 p.m. Should have read this a little bit more carefully, shouldn't I have? Do apologize. 11 p.m. is how many hours after midnight? So from midnight on that day to 12 p.m. would be 12 hours, and then you have to keep going to 11. That's 23 hours later. So I'm going to have to widen this out a little bit. Let's take this up to 25 hours. So I need to go 23 hours later. Wow. Let me write that down for you real quick. Whew. This is why we don't do math in the mornings. So what is the water level? The water level is your Y value. I'm so sorry about that. At 11 p.m. So this is when X is going to be 23 hours. That's 23 hours after midnight. 11 p.m. is 11 p.m. on that day. So now let's trace it here. Trace 23. Much better. Okay. 23 hours later is 2.586 feet. Your Y value right here, 2.586. 2.586 feet. Okay, I apologize about the confusion there, but it's wanting to know the water level. It wants to know the Y value when I give you an X value of 11 p.m. Now, you saw me make a lot of mistakes right there, but eventually we got to it. 11 p.m. means that you are going 23 hours into your day, because once you hit midnight, it would end up being 24 hours from where you started, right? 24 hours from 0. All right, let's soldier on. Number 2. Since the number of hours of sunlight in a day cycles annually, it can be modeled with a sinusoidal function. The longest day of the year occurs on the summer solstice in June, while the shortest day of the year occurs on the winter solstice in December. You can notice in the wintertime, days get shorter. Most of you are feeling that effect right now. In the wintertime, days get shorter. The sun comes up a little bit earlier and it falls a whole lot earlier. That's why it's getting dark right now around 5:30, 6 o'clock instead of 9 o'clock like it does in the summer. And then it says, in Boston, the number of hours of sunlight on the summer solstice is 15.283, and the winter solstice is 9.67. Make a sketch of the hours of sunlight per month for Boston. Use T equals 1 for January. Ooh, T equals 1 for January. So starting at 0, T equals 1 is January. So what's the T value for, well, yeah, let's go ahead and do this. What's the T value for my summer solstice for June? If 1 is January, that would make June 6. So let's bust this thing up here. This will be 6. The winter solstice in December, so the month of December would be 12 then. Right? So you go from 6 to 12. Let me widen that out a little bit. Try and make it as accurate as possible. Much better. All right, so from 6 to 12, and it says that the solstice hours are going to range from 9.067 to 15.283. And in June, it would be up here. In December, it would be down here. Okay, so let's kind of extrapolate this a little bit, because right now all we've got is this one piece of data. Let's kind of extend that. If you were to go backwards, back to the beginning part of January, right? You'd be heading back to this 9.067 if you go back to January this way, but you wouldn't quite hit it because that happens in December. So what I'm going to do is I'm going to come down like this, and I'm going to go just slightly above my 9.067. So this is 6, 12. So the next solstice should happen at 18, 6 units later. So it'd be something like that. Right? Ding. Okay, so let's figure this out here. Your period would go from 0 to 12. So your period would be 12. So B is 2 pi over 12, which is pi over 6. Your amplitude is going to be the top minus the bottom divided by 2. So it's going to be 15.283 minus 9.067 divided by 2. Get a calculator. That's 3.108. Get your K value. Yay! Is 15.283 minus 3.108, which is 12.175. And we're going to do the rest of this assignment in our announcer voice. Write an equation to model the number of hours of sunlight per month. So again, since we're dealing with time on the x-axis, it's going to be f of t is equal to, my A is 3.108. I'm going to use cosine since I started on a hill. Yeah. Cosine pi over 6 of x minus 6. Why did I do minus 6? Because we moved it right 6 units. Plus 12.175. Oh yeah. In a world completely underwater. According to the model, how many hours of sunlight are there in February, May? Okay, so it's asking how many hours of sunlight are there in February and May. This is giving me an x value, actually. If you think about this, February is going to be when x is 2. May is going to be when x is 5. May! I love May. So here's what I'm going to do. I'm going to grab my plotter here, my plotter majig, and I'm going to go to typing in stuff all happy and nice like. Pi divided by 6, open parentheses, x minus 6, close parentheses twice, plus 12.175. I'm going to go to my window. My window needs to be 0 to 20, just so I can see the 18. Why not? Wow. 20, how about that? X scale is 1, Y min needs to be, let's leave it at 0, and since we're going up to 15, let's make the Y max 20. Let's graph it. It's a good graph. That graph. That good graph. I'm going to go to trace 2. You get 10.621 hours of sunlight. 10.621 ERS. May, go to 5. 14.867 if we round up ERS of sunlight. When are there at least 12 hours of sunlight? Oh, this is a good question. When are there at least? So there can be more, but when is the bare minimum 12 hours of sunlight? Now, let's just stick with just 1 year because we don't need to repeat. Let's just do 1 year. Where are there 12 hours of sunlight? Now, there are a couple of ways that you can do this, right? But you're basically looking for X values. So here's what I'm going to do. I'm going to plug 12, this guy right here, into Y2. And watch what that does for me. I'm going to go back here. I'm going to go to Y2, and I'm going to plug in 12. Yay! You know what? Let me restrict my window to 12. That way we're only dealing with 1 year. I'm going to change my X max to 12. That way I'm only dealing with 1 year. So when are there more than 12 hours of sunlight? I need to find these 2 points. Where these 2 points intersect, I want all of this area up in Hura. So second calculate, number 5 is intersect. Scroll over here. Enter, enter, enter. And it snaps to the closest intersection point, which is 2.892. So this is going to be between 2.892 and my next one, 5. Scrolling, scrolling, scrolling. Keep that cursor scrolling, scrolling, scroll. Okay, I'm close enough. It'll snap to the closest intersection, 9.108. And this is months, right? So it's going to be somewhere later February to September. So it's going to be late February to September. So it's not bad. Another way of writing that is 2.892 is less than, less than or equal to, since it's at least, X, T, not X. Look at all these X's on here. Who used all these X's? T less than or equal to 9.108. And you know all these should be T, right? Up here, I should have used T right here because I wrote F of T. How could I write F of T and then use X? That's highly inappropriate. All kinds of interesting stuff on here. Let me make sure I did that. I did it again on this side too. What in the world? Well, I need someone here watching me make sure I'm not making mistakes. So not so simple harmonic motion. It's not too terrible. Coming up with the graph is relatively simple, provided that you follow the information that I gave you on section 3-4 or 4-4 rather. There's really not much you can go astray on. Have a fantastic day.